Hey everyone, welcome to another problem session. So this is question number 10 now. So we are doing JEE. This is advanced paper and paper one from this year. Okay. So this is actually interesting question. Is You have two plates P and Q. They're perfectly black bodies, so these are black bodies. So this thing is giving out radiation in all direction, and so this also giving us radiation in all direction. And uh, and the amount of radiation gives out depends on the temperature. This is a temperature Tp and this temperature Tq. So as a result, say this, I think in this case, this is higher temperature than that temperature. So Tp is greater than Tq. So radiation or heat, another word for radiation, will flow from here to here. Okay. And it says in this case is if you look at how much heat is flowing per unit time. So this is power. So W0 is energy per time. Okay. Power, radiated power per unit area from P to Q. So this is per area. So this is actually what you would call, this thing will be called flux. Okay, because you're dividing by area. You have a power divided by area, or sometimes you call it power flux. You have a similar concept in electricity and like electric magnetic field flux, electric field flux, magnetic field flux. So this flux is a concept like something per unit area, usually per unit time. Okay. So when you have an electric field flux, phi E, you have an electric field per unit area, right? In a certain direction. So because this is a electric field has a direction, so electric field is going that way, and the area is oriented that way. So you take a normal, and that's how you define the electric field flux. But that's tangential, nothing to do with this problem. I just want to tell you that this is also called flux. Okay. Subsequently, two more plates. Now you have a plate. This second situation, you have two plates in between them. Now what going to happen is there will be power flux between these plates and then plates, these plates. The question is call. So now I'm back. So where were we? So we were looking at this. So trying to see the problem. So if you have nothing between them, this is the rate at which energy is being transported from this to here. And now if you place plates whose temperature is not known, you can say this one is temperature, some temperature T1, and this one some temperature T2. So it's going to transfer from here to there, all the way here. And the question is, what is the transfer between these plates, okay, from this plate to that plate? And so this is the answer we have to find. You can see there's almost nothing given here, right? I mean, the numerical value, anything. So students can get really little bit thrown off by this kind of problem. Till you remember that the more energy will be what this guy gives off minus what this guy gives off. That's the total energy that will be transported from here to there. So if you look at a black body of any kind, any shape black body, there is a plate kind or anything, the black body gives off, if it's a temperature T, black body. So power flux should be like energy in time delta T times area is equal to is given by let me see, Stephan Boltzmann Law. So this is the on average, this is the total on average this is happening. So we have Boltzmann, this is Boltzmann constant times T to the power 4, and this T in degrees Kelvin. Okay, so we'll assume that all these temperatures are in absolute, it says actually it has absolute temperature or absolute temperature, same thing, temperature scale. All right, so this is the one that will be given up in that time. So in here W0, so this is the thing they're calling this is the thing we're calling W here in this problem. So you can between here W0 will simply be how much this guy gives off minus how much this guy gives off. So this is going to be sigma T to the power Tp to the power 4 minus sigma Tq to the power 4. So this one equation. Then if I look at in here, how much power gives? Well, this says this one is Ws, but equilibrium will mean that this temperature remains constant. So this and this temperature remains constant. After some time, it's going to happen once you pull the plate, the temperature will become constant, and so the flux through here has to equal flux through here has to equals to flux. I mean, energy can't be accumulating here, otherwise it's going to temperature go up. Energy can't be accumulating here, temperature go up. So let's do step by step. Flux through here, phi1, and that's phi2 and phi3. When all that added up should give me some clue of what to do. Okay, so I'll call it a W1 is W1 W2. So W1 and I use the letter phi. They use the letter W. W1 W2 W3, and so that's a Ws equals to W1 is sigma Tp minus sigma T1 to the power 4. W2, which should equal to Ws, this is because of equilibrium. All this have to be equal to equilibrium. So this should be equal to sigma T1 to the power 4 minus sigma T2 to the power 4, and this is equal to sigma T to the 4 minus sigma T TQ to the power 4. Now if I add these guys up, then it is all Ws because of equilibrium. So I get 3 Ws is sigma, so adding them cancels these guys, and so this Tp to the power 4, Tp to the power 4 minus sigma Tq to the power 4. So this is my equation number 2, and these are the same, so this must equal to that. So W0 equals to 3Ws, and W0 over Ws equals to 3. Let's see what was the question. W0 Ws, so the answer will be 3 here. Okay, if you like this kind of more detailed explanation of these problems, definitely hit a like button. If you have a comment or question, you can ask me those questions, or if you just want to subscribe to this channel, please do so. I'm going to be posting more regularly now because I got some more time. Okay, all right, take care, bye.